This illustrates the birth of Hurricane Isabel, which occurred over the Ethiopian Highlands. And the maturity of these cloud systems as they track towards the west, picking up energy, moving across the Sahel of Africa, gathering a lot of energy over the warm tropical waters of the Atlantic. This storm became a Category 5 and stayed a Category 5 for 3 days in a row, which is unprecedented for a hurricane in the Atlantic, finally making landfall as a Category 2. Now, when Isabel hit the United States, as a Category 2, it was an enormous Category 2. It was about 1,000 miles in diameter. It's absolutely huge. And this was an enormous windstorm for the mid-Atlantic. 3.5 million people were without power for as long as a week or so across a large area of Virginia, Maryland, up into Pennsylvania. In this particular satellite sequence, you're able to track the entire life cycle of this storm. The white shows the cloud tops, and the colors indicate the rain intensity of this system. Now, a little bit more about the birthplace of these hurricanes. We have to focus in on Ethiopia itself. These are called the Ethiopian Highlands. And what we're looking at here is terrain mapping information which was acquired by the space shuttle. So it's very, very high resolution terrain information. You know, the Ethiopian Highlands are a mountain range about 15,000, 16,000 feet tall. And they lie right along the Red Sea. And the Red Sea is an enormous rift zone. It's a crack in the earth where Africa is literally splitting apart very slowly. The moist trade winds flow over these mountains, and as they travel downwind to the west, a ripple develops in this airflow, much like a stream moving over a rock or a log will develop a ripple and eddies downstream. And these ripples or eddies propagate, and some of these develop some spin. But what generally happens is you get a train or a series of low-pressure areas containing cloud and thunderstorms, and we call these African easterly waves.